All right, so today we're going to work on learning target 6 and learning target 7. So I can define the half-life of a substance, and I can determine the number of half-lives that have occurred for a substance. So to get started here, let's do a little daily review. So when an atom releases an alpha particle, how much is the mass number and the atomic number reduced by? So pause the video and write down your answer. So our correct answer for this daily review question here is our mass number is going to be reduced by 4. And our atomic number is going to be reduced by 2. All right, let's take a look at our second daily review question. So now when an atom releases a beta particle, how is the mass number and the atomic number changed? So pause the video and write down your answer. So for a beta particle, our mass number does not change. And our atomic number is going to be increased by 1. All right, so now let's get into our notes for today. So let's talk about what a half-life is. And so our definition of a half-life is the amount of time that it takes for half of a radioactive substance to decay. And so what we can see from this picture down here is we can see it says the words after 1 half-life and after 2 half-lives. We can see the starting amount for a substance, and then we can see it decreases by half, right? We started with 40, decrease it by half, so it goes down to 20. And so with another half-life, it's going to decrease by half again, so it's down to 10. So our bottom line here is it's the amount of time that it takes for half of a radioactive substance to decay. So let's take a look at this example here. So this example tells us that the half-life for this substance is 5 years. And so what we're going to focus on today is we're going to focus on our column for the number of half-lives and our column for mass. So our pattern here to see what happens to our mass or our amount is going to be dividing by 2. So whatever amount we start with, so we started with 100 grams here. So with each half-life, we are going to divide our mass by 2. So our initial amount here, our starting point, that means no half-lives have occurred, so no time has occurred. We are starting with 100 grams. So after 1 half-life, we are going to take our starting amount, so our 100 grams, divide that by 2, and so after 1 half-life, we have 50 grams left. And now after 2 half-lives, we're going to go ahead and divide this amount by 2 again. So we'll go 50 divided by 2. And so after 2 half-lives, we'll have 25 grams left. And now for a third half-life, same thing. We're going to take our 25 grams that we had, divided by 2, and that gets us down to 12.5 grams. And so what we see down at the bottom of the screen here is we just see a visual of that. We start with 100 grams. After 1 half-life, we have half of that left, so our box is half smaller. And then after 2 half-lives, we reduce by 2 again, 25 grams left. Divide by 2 again, and 12.5 grams left. All right, so why do we care about half-lives? Well, we can think about it in terms of how do we know how long ago dinosaurs lived? And so we have these isotopes. So we have carbon-12, which is a stable isotope. And then we have carbon-14, which is an unstable isotope. And so with those isotopes, we can figure out how long ago those animals lived. So carbon-12, since it's stable, it stays the same. But with carbon-14, it's unstable. And so that amount is going to decrease as time goes on. So that carbon-14 gets lower due to radioactive decay. So that kind of ties into what we were talking about in our other learning targets. And so we can see here that carbon-14 is going to be decreasing. And so we can figure out how long ago these dinosaurs or other animals lived. So now let's take a look at this example here. We are going to fill in our number of half-lives and the mass. And our problem it tells us here is how much of a 100-gram sample of carbon-14, which has a half-life of 5,730 years, will be left after 3 half-lives. So we can see no time has occurred, so we're starting with 0 half-lives. And so our starting amount of carbon-14 is going to be 100 grams. So now let's figure out how much is left after 1 half-life. So after 1 half-life, we're going to take our mass and we're going to divide it by 2. So we take our 100 grams and we divide by 2. So after 1 half-life, we have 50 grams left. Now let's figure out how much is left after 2 half-lives. So 2 half-lives, that means we need to divide our mass by 2 again. So 50 divided by 2 gets us down to 25 grams of carbon-14. And then our third half-life here, we're going to take our mass and divide by 2 again, and so we get 12.5 grams. And there we have it. So how much is left after 3 half-lives? Well, we have 3 half-lives right here, and that amount would be 12.5 grams. So we're not going to worry about this time column yet. So you can see that our time is increasing, but we're not going to worry about the time column yet. We'll worry about that in our next lecture. Let's go through one more example here. So for this example, we have a sample of strontium-90, and it has a half-life of 10 years. So we want to see how long it's going to take for a 300-gram sample to decay to 75 grams. So what we're going to be concerned about again here is filling in our half-life table and filling in our mass. So again, at 0 half-lives, no time has passed. We are just starting with 300 grams. So now after 1 half-life, we're going to take our mass, divide it by 2, 300 divided by 2, and that gets us to 150 grams. Now let's figure out how many is left after 2 half-lives. So we're going to take our mass and divide by 2 again. So 150 divided by 2, that gets us to 75 grams. So now our table is filled in. So if we want to look at here how long it takes for a 300-gram sample to decay to 75 grams, well, we have our 75 grams right here. So we got to look at our table and figure out how long did that take. Well, we know it took 2 half-lives. And the amount of time it took, well, we can look at our time column and we can see that it took 20 years for 300 grams of strontium-90 to decay to 75 grams. So bottom line here, our number of half-lives. You start at 0, and then you go to 1, and then 2, and then 3, and so on. For our mass, our pattern here, you're just going to keep dividing your mass by 2. And that's our lecture for today. So reach out if you have any questions, but otherwise you could go ahead and complete your remaining assignments for today. Have a great day.